The last way we're going to use the angle addition postulate is with angle bisectors. Now, when we did constructions, we created angle bisectors, and what you learned is that a bisector cuts things in half. So an angle bisector creates two congruent angles from the whole. The two parts are congruent. So here's the example. I have a drawing, and you can see there's 120 degrees over here. And it says that BD bisects angle CBE. So I'll just highlight that really quickly. So this angle is bisected. What does that mean? That means each part there is congruent, so they have the same measure. So what I'm doing is I'm going ahead and putting an X, since X marks the spot. So I'm going to say this is X, and if they're congruent, that one has to be X as well. Now that I've done that, knowing what a bisector is, I still use the angle addition postulate. So I say the sum of the parts equals a whole. Now, hopefully it'll be obvious when we do this that if you see something that looks like a straight line and it doesn't look like it bends, you are allowed to assume that it's a straight line and it doesn't have 180 degrees. That it is 180 degrees. So I'm going to say that 120 plus x is 180 degrees. Now I'm going to combine these two terms here. So I get 120 plus 2x equals 180. Subtract 120 from both sides. I get 2x equals 60. Then I divide both sides by 2 because I want just 1x, not 2x. And that gives me x is 30. I'm trying to look for the measure. No, don't stop when you get x. Always make sure you're looking for the right thing. And what I'm looking for is the measure CBD, which does happen to be x. So my answer is 30 degrees. There's another example very similar to this that you were expected to do on your own, the individual practice. So hopefully this helped. Now, sometimes you will be expected to draw an angle. So I might say, oh, BD bisects angle ABC, BE bisects angle DBC, and here's the measure of one of them. Find the rest. So what you want to do is draw the angle. So I'm drawing an angle. It doesn't matter if it's acute or obtuse. Just draw an angle. And this one is actually drawn incorrectly because it's too big. But that doesn't matter. So I'm going to say B goes right here. Why? Because there's B. It's in the center. It's the vertex. And I know there's a ray, BD, that bisects this in half. I'm just going to draw the segment. Oh, well, I'm going to put, oh, by the way, I need to put in point A and point C. You can have A on the bottom or A on the top. It doesn't matter where you put A or C, as long as you can have angle ABC, which is the same as angle CBA. Now I'm going to go ahead and draw the ray BD, which bisects this angle in half. Did I actually draw it so it cut it exactly in half? I don't know. Doesn't matter. Now, BE is going to bisect angle DBC. Which angle is that one? So that's this angle right here. So we're going to cut this angle in half with ray BE. So let me go ahead and draw the ray and put my point E. Finally, they tell me that angle EBC is 14 degrees. That's EBC. Oops, I have that in the wrong side. It goes over here. Did it really matter? No, because these are two congruent angles. This is a bisector of the yellow angle, so both pieces are congruent. Technically, I should have done that 14 first. Now, if both of these are 14, how much is this piece that's yellow? It's 28 degrees. Well, we're kind of going backwards. Remember, BD bisects the big angle in half. So if that's 28, the other half is 28. And if I'm trying to find angle ABC, then I just need to add the 14 plus 28, or 56 degrees. So thinking further, in angle bisector problems, you usually don't know two of the angles. So why are you still able to set up an equation? How do you go backwards if you know the measure of a bisected piece? So a lot of times we might say, oh, these are all the angles in their relationship, but we didn't tell you the numbers. But we'll give you a piece. How do we go backwards in that last example? And for our whole angle lesson today, what basic principle do we use to set up problems involving the angle addition postulate?